Hi, everyone. Welcome to our presentation of RedXOR. RedXOR is a malware that we found earlier this year that has some ties to Chinese nation state. My name is Joachim Kennedy, and I'm a security researcher at Intezor. Otherwise, I also have a open source project that I maintain that is used for reverse engineering gold binaries.
Hey everybody, I'm Abigail. I'm a security researcher at Intezor. I specialize in malware analysis and threat hunting. And I also wrote the ELF Malware Analysis 101 to help beginners in the ELF malware analysis world. So this is what we are going to cover today. We will start with a small introduction to Linux malware. Then we will talk about RedXOR. We will explain the rootkit that it uses, its behaviors on a victim's machine. And lastly, we will explain how we connected RedXOR to the Winnti umbrella group, which is a Chinese advanced persistence group. Now, before we talk about Linux malware, let's understand the Linux market share a bit. So it's no news that the Linux market share in the desktop world is really, really low. Most of desktops nowadays run on Windows. However, speaking about cloud workloads, Linux is the predominant operation system. Now, this makes sense because most of cloud workloads are actually servers, and most servers use Linux because of the nature of this operation system. And this really affects on what we see in the Linux malware threat landscape. It's kind of makes sense why we see so many coin miners and botnets, because their nature is to take advantage of other computing services. We also see ransomware, which, unlike coin miners and botnets, are more targeted to specific services, like file hosting services such as QNAP. And we also see ransomware that targets VMware ESXi. And we also see backdoors, which are more, their goal is more doing espionage. And as for the threat actors behind these malware, along with the malicious individuals, we have nation-state groups, and we have cybercriminal groups, where Team TNT is the most popular cybercriminal group nowadays that target Linux systems. Nation state that historically targeted Linux are Russia, North Korea, and China. In Russia, we have APT29, APT28, and Turla. In North Korea, we have the Lazarus group, and in China, BlackTech and the Winnti umbrella. Now, an interesting fact here is that a high percentage of tools that these nation states developed to target Linux were actually first developed to target Windows. For example, Wellness, APT29, DACLs, which was developed by Lazarus Group, and Plead, which was developed by BlackTech. So now that we have some background about Linux malware, let's talk about RedXOR. So RedXOR was uploaded to VirusTotal as a Polkit daemon. Polkit is a known binary that runs on a Linux operation system. It had only one detection in VirusTotal when we detected it, and it was uploaded from Indonesia and Taiwan. So this sample caught our eyes because of different reasons. One of them that its name was Polkit, but it had no connection to the actual Polkit binary. So we investigated it, and these are the capabilities of this malware. First of all, it's a backdoor. It has reverse shell capabilities, which are implemented by a pseudo terminal. It has file manipulation capabilities, such as uploading files, downloading files, deleting files, and so on. It has a rootkit capability, which Joachim will explain right away. And it has a reverse proxy capability, which is based on ReinetD, which is open sourced.
When it comes to rootkits on Linux, there's sort of two approaches that can be taken. First approach is to use sort of a userland-based rootkit. And one way of achieving that is by using a functionality that's part of the system called LD preload. LD preload allows you to tell the linker to load another shared object before any other shared objects are loaded. And when you're in that state, you can then sort of change the functionality of the other shared objects when they get loaded. So you can then sort of manipulate how those sort of functions behave. You can, for example, use it to filter out your process from sort of function calls that will list all the processes running on the system, so you can hide. Now, it does have some downsides that it leaves traces on the system that can be discovered, because they need to be there so the system itself knows that it needs to load those sort of shared objects. The other approach is to use a Linux kernel module. Now, the benefit here is that it's way more stealthier, but there is an upside to it too. It's way more complicated. What you actually have to do is to compile the module for the specific version that the kernel is running on the system. So this is not really a good favor for like the attacker. Now, there are sort of projects out there to sort of help vendors that have drivers and stuff that is not part of the Linux kernel tree. And one of the most common one used is called DKMS. So what DKMS does is that when it detects a new kernel on the system, it will recompile the module against this new kernel so it can be loaded. Now, if you're an attacker, this is not really something you would want to use, because it does require that you put the source code to your rootkit on the machine, so when the kernel changes, you can recompile it. The rootkit that RedXOR is using is called Adore NG. It's an open source rootkit that's hosted on GitHub, and it's sort of been taken by this threat actor and sort of used for their advantage. The way we identify this rootkit was to sort of see how the malware actually interacts with it. Here we see a sort of a code snippet from a function called checklmk. And what it does is first creates like a file in the sudo proc file system, and then removes it. And then it checks for its user ID and compares that to a sort of a hard-coded value. And this piece of code almost completely translates to this sort of the C code that is in the repo for the client that's provided by the rootkit. Here we can see that it's creating this sort of file, it removes it, and it checks against sort of a hard-coded value. And if it gets what it's expecting, it knows that the rootkit is available. Otherwise, it knows it's not there.
So this is how RedXOR behaves on a victim's machine. Upon execution, it will fork itself, and by that it will detach itself from the shell, and the parent process will exit. Then it will create a hidden folder, and under this hidden folder, it will create this file, which actually behaves as a mutex because it is locked by the process. This means that if another process of RedXOR would have run on this victim's machine, it will exit right away because it will check if this file is locked or not. And it will also move itself under this hidden folder. Next, it will create a persistence via init script under these paths. Init scripts will run once the system will reboot. So this is why it makes a persistence. And this is how it looks like. This is the script. It's really straightforward. It just calls the binary from within the hidden folder. Now, the binary holds within it an encrypted configuration file, which holds information about the C2, such as password, IP, and port. And it also holds information variables regarding the proxy. Now, as I said earlier, RedXOR has proxy capabilities. However, the samples that we analyzed didn't use it. the configuration file was decoded via this RexXOR scheme, which basically receives the buffer and it uses the buffer length as a key. So it iterates over the buffer, and the XOR key for each iteration is the buffer length plus itself. So this is a Python implementation of this scheme. And this is how the make HTTP data function looks like. Every post request is sent via this functionality. We can see the hard-coded RedXOR login directory, and we can also see the JSession ID variable within the cookie header, which is really interesting, and we'll see it in the next slide. And also here we can see the encryption scheme, encoding scheme, which is the RedXOR functionality that we saw before. Every body of the HTTP request will be encoded via this logic. And this is how the communication looks like between RedXOR and the C2. Upon execution, it will send the C2 its password. Then the C2 will reply all right with the JSession ID equals 0000. This is actually the instruction from the server to RedXOR to send system information. So we can see in the next post request sent by RedXOR, it will hold the system information. Okay, again, decrypted with this RedXOR logic. And the C2 will reply with JSession ID equals 1000, which is actually ping. So from this point, and it will ping to the C2, the RedXOR to the C2, until the C2 will send another instruction. These are all the supported instructions that RedXOR knows how to identify. We can see the system information and the ping, which we saw before in the example. Underneath the ping, we can see the install LKM, which means that the rootkit will not be installed by default, but via a command from the C2. Now, we know that XOR DDoS and Palm Linux are both related to the Winnti umbrella. We found connections between RedXOR to these two samples, which made us believe with high probability that RedXOR was actually developed by the Winnti umbrella group. The first similarity that we saw is the usage of pseudo-terminal. In RedXOR, it is used by Python and PTY library. And in Palm Linux, it is implemented in C. Another similarity is the usage of XML file listing for directory listing. Now, both Palm Linux and RedXOR has directory listing capabilities, functionalities. Both functionalities use XML to send the information back to the C2. And they use very, very similar attributes as well, such as a path name, type, user, permission, size, and so on.
There's also similarity between the rootkits used between these malwares. Both Pwn Linux and RexXOR DOS uses another rootkit called Sutoruso. This is also an open source rootkit that is available on GitHub. But the way that the interactions and some of the sort of connections between them goes deeper than that. Here, we have actually the same sort of same kind of function name, both to check for this kernel module. On the left, we have the RedXOR one, which we showed earlier, where it checks for that specific file and then the user ID. Now, in the middle, we have RexXOR DOS and Pwn Linux that's using Sutoruso. What the actors have done here is that they've actually changed this interaction in the source code for the rootkit. Normally, it would actually communicate via a socket and send ioctls, but they've rewritten the rootkit to instead have the same behavior as the rootkit that's used in RedXOR, where it's talking via a file. There's also another interesting connection between these malware, and that's the use of this function called Ltone. Ltone is used to change the owner of a file to a different user or a group. And what's very special with this in these malware is the user ID and group ID that's being used. Here, on the left, we have a call here in Pwn Linux, and on the right, we have the RedXOR. What we can see from these numbers is that they're very large and very, very likely not valid IDs on the machine, because we're talking of the upper level of the available space of an integer. Now, this call actually makes sense in RedXOR because that's how it's communicating to the rootkit to hide a specific file. And these values are magical values that is hard-coded and sort of interpreted by the kernel module to know that I need to hide this file. But Pwn Linux rootkit doesn't use this behavior, but it still has this functionality in there and actually will use it. One of the use cases where this is executed is at the end of the main function before it goes in and handles all of the the processing with the C2 information. And here we see that call. And the interesting part here is it actually takes the argv argument from the main function, which is the path to the current binary that's being executed. So it uses then this instruction to communicate with some rootkit to hide, but the rootkit that it comes with does not understand this command. And other places where this is used is in the processing of the instruction that comes from the C2. Here we can see in the case of 1 through 10 that it has, in the case of 11 through 12, where it does have a function that calls a hide file. And this is how it's supposed to communicate with Sutaruso. It will send the ioctl command to hide this file that it wants to hide, and the rootkit will do that. But interestingly, in the case 13 and 14, we see the actual handling to talk to the adore ng rootkit, which is used by RedXOR. So clearly there is a understanding and expectation that the Pwn Linux may know that this rootkit is already on the system, and it may have to undo what it's already have done. And there's other connections that sort of points to the Winnti umbrella. Here's sort of a list of some of the things that we've listed in our blog post. It all goes from the way of using sort of a custom XOR scheme to encrypt the data, similar in the service names and sort of general code flow, and even sort of the build system they've used to compile the malware. More of this you can read about in the blog post that we published earlier this year. So just to conclude this presentation, here we have talked about a new sort of targeted attack against Linux environment, and it's done through a malware called RedXOR. It's a very, very stealthy backdoor that uses a rootkit that once it's on the system and has sort of got its grip on it, it can be really, really hard to detect that it's on the system. And through sort of like its similarity to other malware that's already been used by threat actors that have been tracked under the Winnti umbrella, we see that this one is highly likely also produced by one of the same threat actor. Thank you for listening to our session, and I hope you guys enjoy the rest of the event.